Okay. I think maybe I don't think the internet was the problem. I think I crashed the system over here, apparently. I'm not sure. Trying to see if we've got anything actually going right now or not. It's hard to tell. I think, let me see. No, that's not what I want. Don't do that. Well, oh, there we go. All right, I think we do have one going. All right, so we'll just kind of start over. We were a couple of minutes in, and it just sort of crashed everything. It wasn't the internet issue this time, though. It was, I might have, Fusion is going in the background, Fusion 360. Might have had too much stuff going, and it just couldn't take it. So we will see. We'll see where we go from here. I don't know. I'll have to link this one again later because I think it probably isn't listed in the same spot. But anyway, we'll fix that later. All right. So all I had said previously was that I printed a couple of new samples here. A very brightly colored fluorescent PLA. I printed a larger version of the Prusament polychromatic that we printed last time. We printed a half size of this version. And then I did a copper fill, which we did weigh it, and it was 24 grams, where, you know, a typical one is 10 or 11 grams. So it is noticeable. And what I was saying was, before everything shut down, one of the things I was saying was that these are supposed to be able to be sort of finished like metal, but you have to be careful because if you're thinking about sanding or anything like that, then you might think, oh, I'll just use a Dremel or, you know, some kind of sanding tool, electric sanding tool. That is maybe okay, but you have to keep moving around a lot because the friction from that sanding can actually melt the plastic parts. So I did say that I would probably try and pick one of these nice flat faces and try to polish it up by hand and see if it, you know, does it look copper. That one's actually not copper, that's bronze, from Proto Pasta. This is its little bag, bronze fill from Proto Pasta. It also says you can anneal these, and then I'd mentioned that I do have a little oven coming that we can possibly use for annealing and dehydrating. All right, then what I was doing was I was going over here, and this is where it kind of crashed everything on us. So this is the control panel that it's fluid. So there's different kind of skin overlay type things for Clipper. Clipper's the controller, I guess we would say. So it's taken the place of the firmware like Marlin, but it's not exactly the same as Marlin, but it's doing that job. And it's running on a Raspberry Pi on this little printer over here. So our little Voron. So it's the one I've currently got. I think it's the only one. Yeah, it's the only one that I currently have running Clipper. And so what the idea with Clipper is that you have a control board on your printer. So we've opened up on our Ender over here. We've opened up this box in here. We actually replaced the whole board on this printer with a SKR Mini E3, all that kind of stuff. So there's a control board that normally that board would go in and process all the G-code commands, interpret them to mean some kind of series of stepper movements, have the stepper drivers on those boards actually go and move the steppers to produce whatever kind of motion and extrusion you're trying to do. So what Clipper does is this printer has, actually, we should be able to see them. They're on the back, if I can get it turned around here. So there we go. It has, actually that's a SKR Mini E3 version 2. So it has, I think that's the exact same board that we put in here. Not the literal same board, but the same type of board. I think that's the same board that was in here. And it also has a Pi. This one's a 3B Plus. So it's got a Raspberry Pi over here, board, power supply is underneath it and everything. And what's going on here, Clipper runs over here on the Raspberry Pi. So Clipper takes over most of all of the control. So it takes and reads the G code, interprets the G code, and sends commands over to this board, the SKR, where normally all that stuff happens. And this board, all it really does is stepper control and collect data. So it collects the thermistor data. You still have your thermistors plugged in over here, so it's getting temperature data, stuff like that. But no processing really happens over here. And why that's useful is that this board is way more powerful processing-wise than these boards are currently. So what it lets you do is a couple of things. It doesn't really matter anymore what this board is. You could go get an old 8-bit board out of a 5 or 6 year old printer that's limited by the board itself. So the board just can't process stuff fast enough. And so the speed is limited by that board. And you could run Clipper on your Raspberry Pi, and this thing is certainly capable of controlling the steppers no matter what printer board it is. The stepper motor control, these are the stepper drivers. The blue is the heatsink on top of the stepper driver. And those are what's making their steppers move. And they can do that much faster than these boards, the computing part of these boards can process G code and send it to them. So they're not the limiter. And so by offloading the processing over here, then you've suddenly sped your board up. So you went from a board that was limited on the things it could do just by the processor it was running. Now these boards, this is a 32-bit board, so it isn't as limited, but it's still limited compared to the Raspberry Pi. So what it lets you do is now I can do all sorts of kind of co-processing type of calculations that I can look at the G code. Well, the Raspberry Pi can look at the G code, see what's about to happen, and make adjustments faster than even the 32-bit boards can do. So in particular, one of them that's interesting is input shaping. I had to think of the name of it, input shaping. So what input shaping does is you actually go in, attach an accelerometer, so that's something that measures vibrations or changes in motion, stuff like that, acceleration. Attach an accelerometer to your printer and take some baseline data of the resonance of your printer. So using that data, your Raspberry Pi can take your G code and look ahead at the movements that are about to be made and say, oh, whenever we make a right-hand turn really fast like that, the machine is going to vibrate and put this pattern, this ringing or ghosting pattern on the surface of my print. I don't want that. So I am going to instead of just slowing down, I'm going to still go at the same speed, but I'm going to move opposite of that ringing pattern. So I'm going to kind of do like a wave cancellation type thing. I know it wants to go this way. I am going to shift it off from that so that the result is a straight line. So you can still print fast without ghosting and eliminate that ringing part without, the normal solution would be I'm just going to slow down and not ring. I'm going to make corners really slowly or whatever. Slowly, is a relative term. But I'm going to do that slow turns and slow acceleration changes so that I don't get all that ringing. Just checking to make sure we're not buffering too badly. It gave us a little warning here. So that's what Clipper does. And Clipper, I do believe it can run on other processors than a Raspberry Pi. I've never used it on another processor other than a Raspberry Pi, though. So that's one of the downsides. I think BeagleBone can probably do it. You could just run some little PC, some old laptop or whatever that you're not using anymore. It could be the thing that hosts Clipper. So it is possible to do other things other than Raspberry Pis. I just never have done that. So the other advantage is, so here we are. Oh, well, I was going to show this. This is where we crashed last time, which it just isn't going to show that. Oh, there it is. It's just covered up. There we go. So we used this Raspberry Pi imager last time to put Octoprint on the SD card. I don't know if you've ever used a Raspberry Pi or not, but the Raspberry Pis, the way they work is there's just a little SD card. Well, it's actually behind there. You can kind of see it poking up. And the operating system resides on there. So to install a whole new operating system, I could take this Raspberry Pi, put a different SD card in it, and now when I boot it up, it's a retro gaming emulator. I put a different SD card in it, it's running Clipper. Put another SD card in it and boot it up, and it's running Octoprint. So they're easy to change their function just by putting the correct SD card in there. And so we did Raspberry Pi Imager, and we put in, let's see, I think it was specific purpose 3D printing. We put Octopi. That's what we put on there. But they have Clipper on here and main cell, which are Clipper, either one of those. One of them, Clipper Pi, Octo Clipper Pi, basically uses Octopi and Clipper together. I've never really done that process, but here's one that is basically what I'm doing. And so you can just click the button, put this onto your SD card, set up your login. Remember, we had to do that last time to actually get it to connect to our network. And you've installed Clipper. I haven't tried it with this, so it might be a little more complicated than that. I should try that and make sure that it's as easy as I'm saying it is. But I don't want to do that right now. It takes a 15-ish minute process to flash that image over to your SD card, and I don't want to do that right now. Once you get it done, though, now similar to Octoprint or Octopi and Octoprint, that's terminology that I don't exactly know the difference in. I think Octopi is what's on the Pi. Octoprint is when you're logged into the web page, maybe, but that's not important. Anyway, similar to that, you can log into a web page, and now I have access to the printer, the Voron printer, or whatever is running Clipper. And unlike Octoprint, I can actually change firmware settings. So they're not really firmware anymore. Now I can change configurations. I showed you this last time, but I've got over here printer.cf. I actually have several configuration files, but here's one. And I can edit it, and I can change any of my settings. I can add new settings. I can add a BL Touch. I can do whatever I want to. Hit save and restart, and I have made that change on the printer. On Clipper, which is controlling the printer. Now, remember, all of the control is over on the Raspberry Pi now, versus being on the board, the controller, the processor on the SKR board is what that printer has. I can create new macros. You can see, let's see, go over here. There's this little list of macros. Maybe there's a particular thing you want to happen, a particular heating routine or cooling down routine or whatever. You can just create your own little macro and add it to the list here. You can set your speed limits and acceleration limits over here that are normally buried in the firmware. I can obviously do the stuff that Octoprint does, where I upload jobs and print and monitor. I don't currently have a camera attached to this one. I assume you can do that, or maybe that might be why some people still use Clipper and Octoprint together, because Octoprint does have a lot of nice time-lapse camera setups. It has a lot of plugins that you can choose, whereas Fluid doesn't have. You can write your own and create your own, but it doesn't have this pre-existing database of stuff like Octoprint has. And so if I use Clipper and Octoprint, I still have access to that set of plugins. To me, it's just a little bit slower. Like it's a little, the chain is just longer of how to actually use it. So I've never bothered to do that. And I wasn't that worried about the plugins that Octoprint provided. If I were doing time lapses, I think that would be because the time lapse setups in Octoprint are really good, particularly Octolapse. And I don't know that exists as well over here in the Clipper environment. But that's one. I do have a video probably from last summer installing Clipper the older way. So if you want to look at it and you have a Raspberry Pi that you can actually use, then I do have that out there. I will at some point go and try the Raspberry Pi Imager version of installing it and see if that is simpler, because it's not complicated, but there are lots of steps in it. But they are spelled out pretty exactly if you can find the right set. That's the problem, is it's a little bit cumbersome to get it set up the first time. I'm hoping that the Raspberry Pi Imager makes that much simpler than it used to be. Anyway, that's why Clipper, those are some of the reasons anyway, that Clipper might be a thing you're interested in, assuming you have a Raspberry Pi to run the thing. All right. What I really wanted to do today, though, was some stuff in Fusion 360. So when we crashed last time, I was also saying, this is the toaster, dehydrator, rotisserie, air fryer, all this kind of stuff. This is the thing I decided to order. Should be here Wednesday to try two things. Try annealing some of these prints that can be annealed, and try dehydrating some of the filaments that seem to have too much moisture, particularly the TPU stuff. So we'll see if this particular machine will do it. I want a standalone machine for a couple of reasons. One is that you might not want to put filament plastic in your actual oven that you cook food in. Might not be a thing you want to do. And the other thing is, most ovens that you cook food in don't go down to a low enough temperature to not melt the plastic or the spool holder or whatever, but still dehydrate it. Where these toaster ovens, they can go down low enough to do that. So that's why I want a kind of standalone thing for those two reasons mainly. I don't think I'm too worried about the plastic in the food, but that's still, plastics do off gas whenever they get heated up, and so there is the possibility of some carryover between you just dehydrated your filament and now you put some actual food in there, and maybe it reabsorbs some of the stuff that off-gassed from the dryer. So it is probably a good idea to keep your work oven separate from your cooking oven. All right, so that's what that was pulled up for. All right, let's go to Fusion 360. Oh, it thinks I'm offline because maybe we did crash a minute ago. What? I don't want to work. Oh, there it went. It went back to being connected. All right. So one of these times previously, I had mentioned that there were some new plastic tools in Fusion 360. I finally figured out how to get them to install. I had such an old version of Fusion 360 that it didn't automatically update, so I had to uninstall Fusion 360 that I did have, install the newer version, and now it seems to be keeping up with updates. It's it just updated something 43 minutes ago. So and as a part of that process, now I have this little plastics tab. I believe I had to let's see, if you go to the extensions, I think I had to enable this product design extension. So these extensions, they're not all free. I have the education license, so if you have an education license, this should all work. If you have a different license, maker license, or whatever the other licenses are, this may not be a free thing. It might have a cost associated with it. I don't know. But anyway, I enabled the product design extension, and that put in these plastic rules and plastic design tools, plus some other stuff that I haven't really used. Design advice, that might be interesting. But what it does is, one of the things, at least that I end up doing a lot, is using 3D printing to house something. So like I've got this guy over here. It's going to be off the screen. Where are we at? There we go. Got this little plastic housing that I've got this ESP32 stuck in with some other stuff. And that's fine. That's good. I mean, that's a normal use for 3D printing, is you want to print this thing. But I wanted a snap fit. You can kind of see these little parts. I don't have the lid for this right now. This little parts up here. And yeah, you can model those, but inside the plastic tools of Fusion 360, they have snap fit tools ready to go. So you basically, you have to set up one thing. Now, I will say that this is assuming, Fusion 360 here is assuming that what you're trying to do is something for plastic injection molding. So it's not really the program, Fusion 360 doesn't really know that you're going to 3D print this thing. So it's thinking you're going to injection mold it. And these rules, these assigned plastic rules, it is, you know, basically going in and, oh, what's a good radius for injection molding of this machine, or a good thickness, or, you know, something like that. So you do have to assign these rules. They may not be rules for 3D printing though. So you still do have to come in and think about, well, is that actually going to work when I 3D print it? I was concerned that these little, let's see if I can find it, these little snap tabs right here in 3D printing would be pretty fragile. So far, because I'm printing this laying down flat, and so they're very weak, they're just stacked layers on top of one another. So far though, it hasn't been a problem. I've been relatively careful with them. I did print another version of this somewhere. I don't think I have it handy. Oh, maybe I do. Yeah, we do. Let's just go over here. Go down there. So I did print another version of this in nylon. Nylon is way more tough, so it's much more flexible. And again, I did print it laying down flat, so the little springy parts are in their weaker orientation, but they've all held up, and they do. Here's a lid for this one. They do snap together once I get them lined up. I think this is the lid for this. This may not be the lid for this piece. Yeah, there it goes. So they just snap together, hold your part together, and then you can take it back apart, and nothing's broken yet. So, and these were all made with the plastic rules here. There are other rules for like creating a boss. You want to screw them together. It'll create the matching bosses on one side for the hole and one side for the threaded region. It's got a little rest thing here where maybe you've got a curved surface and you want to mount something flat on it. You can create a little rest there. Oh, this is just a patterning tool. Here's a geometric pattern so that you can put a gradient pattern on the surface. I don't think I'd want to do that if I were FDM printing it, because that's going to add a lot of print time. It doesn't add a whole lot of new material, but making all the little movements could really slow it down. Now, if I was resin printing it, I think that would make a good choice. I didn't actually try this one, so I don't know what it does. I also saw, let's see, I think over here in solid. Also saw this was new, automated modeling. This is similar to a couple of weeks ago we did generative design. This is similar to that with without all of the FEA type analysis stuff. So it's more of a get from point A to point B and avoid these obstacles in the most direct route. I might want to try that. I haven't used that before either, but it does look like a interesting tool. It's not really a plastic based tool. It's just more of a design inspiration tool, I guess. So what I think we have enough time to make us a simple little snap fit case here. And you can, because that's something that I see a lot of people at school, they try to print housings for things, and the housings they come up with generally are just boxes, which you could just make a flat box, and why print that? You know, just make it out of flat sheet or whatever, or buy a project box from online or and something like that. So usually if you're going to 3D print this, there's a reason that you don't want to just buy an enclosure that already exists, because it'd be way cheaper not cheaper necessarily, but it would certainly be faster to do. So what you do is you pick your material. I have just been using the ABS. They don't really, you can create your own, but they don't really have like a PLA, and it really wouldn't matter anyway, because these are assuming you're going to injection mold. So I've just been using the 1.5 millimeter ABS. There is a thinner one. Oh no, that's just in inches. So actually 0.1 inches is thicker than 1.5 millimeters. But I've been using that one. And oh well, I don't have any. I don't have anything to apply it to yet. So let's build us a little box. So let's see here. Something like that. Let's give it some. Let's see. I am in millimeters. So let's say let's just do 80. I have no real reason for it to be any particular size, but there's our size. 80 by 100 millimeter box. Let's go ahead and round off the corners here. All right, that looks good. And then we will extrude this guy up 20 millimeters. That looks fine. And let's make it more rounded. So let's round this edge at, let's see, 10. Yeah, we'll do 10 so that it, oh no, let's do 8 so it has a little flat bit there. And we'll do this one also. There we go. All right, so there's our container, but right now it's a solid block, so we can't actually snap it together. Now I have something I can apply our plastic rule to. So we will select this guy and apply our ABS plastic rule so that it can do the other things that it wants to do later on. It did change the color and it assigned a material over here. Or well, it assigned a material and this rule, which is basically what's a good thickness for it, you know, all that kind of stuff. I need to separate this into two halves. So far I haven't done anything that's specific to the plastic rules. This is just modeling. I'm going to create, let's go back over to, let's see, an offset plane. No, let's do mid-plane. And we'll just do the mid-plane between this top surface and this bottom surface. So it just puts it right in the middle of those two surfaces. So now I've got this plane that I can use. I'm trying to separate it into a top and a bottom. And I'm also trying to remember how do you do that in Fusion 360 versus how do you do that in SolidWorks. I do like SolidWorks, and I've used it more than I have Fusion 360, but a lot of times it seems like Fusion 360 is maybe a little more intuitive than SolidWorks is sometimes, except for right now because I am trying to remember how to do a split line, which is probably not what it's called in here. Let's see, probably modify there. It's going to be in here. Split face or split body. We want to do a split body. All right, so the body to split is the peel box thing. Splitting tool is that plane we just made. And now I've got two bodies. If we look over here, I've got the bottom and the top. So we could rename them. So apparently that one's the bottom, just to keep track of them. And that one must be the top. And I kind of like the top to be on top. There we go. So now we can look at either one of them. It would probably be good to go ahead and hollow them out. So let's hide that. Let's hide that sketch plane because it's getting in the way of everything. Oh, it's in the construction plane. There we go. Yeah, it's in there. Hide that. All right. Let's shell this out. Modify, shell this guy. And so it has assumed this value t. And if you look over here, well, I'm just trying to zoom in. It doesn't actually scale the letters, but it's 1.5. That's because we assigned a plastic rule that this ABS is 1.5 millimeters thick. So it's going to assign the shell that thick. So you can modify these things. Maybe you want the walls of your part to be a certain thickness based on your nozzle diameter when you go to print them, or the layer heights you're going to use, something like that. And so you could assign this T value to be that thickness you want your parts to be. So we'll do that. Let's hollow out the top also though. So we'll just click that shell. I think that's the shell command. Yeah, there it is. And it does the same thing. All right. Let's go to the bottom here. Now I want to add my little snap fit pieces. So what I want to do to create the snap fit pieces is, first of all, I need to create a some kind of marker of where these snap fit pieces are going to exist. So in create over here, there is a sketch. So I'm going to create a sketch. I'm going to create a sketch on this top surface. And all I need to sketch are points. So I just need to create a point, or 2 points. Let's do a point here and one here. And then we can locate those however we want to. Let's say that looks like if we did that 15 millimeters. Let's do the other one 15. Maybe that's too close together. Let's do it, make them 10. We can make that a variable also, where it's the, I want it to be on the other side. Oh well. So that it's more dynamic. If we change stuff, we can change it more easily. But we'll keep it this way. So that's all I need is I just need these points to locate my pins. Did it create them? Or do I, oh, I have sketches turned off. There we go. There they are. So now, if I go to the plastic tab, I have this snap fit tool. And it automatically said, oh, you must want them. I had the sketch still selected, and it goes and finds all those points, and it knows that you must want the snap fits to be on those points. Now, they are turned the wrong way, but they have a little tool here that lets me align them the way I want them to be aligned. And not only is it creating all the geometry for this based on that rule that I set up for the ABS, which I can change any of the little settings I want to over here if I want to. Maybe I want to make them wider. So D is their width over here. They give a little diagram of what dimension relates to what size on the snap fit. Maybe I want them wider because I am going to 3D print these, and that looks really fragile. Right now it's T1 times 2, where T1 is one of the variables assigned in the rule. And let's just make it T1 times 5. And now they're wider. But not only is it doing this, let's turn the top back on. And it's, uh-oh. It didn't make our, maybe because they only partly protruded into it. They didn't actually make the rest of our part here. I think they're too short. Oh, and they're rotated the wrong way. Tiny. Oh, it's making them on top of the other ones. I'll have to figure out. I actually don't know how to undo them. Let's cancel that, and let's undo them, or let's edit them down here. So down here at the bottom, okay, that's on the screen, yeah. Down here at the bottom are your timeline, kind of like your part or your history, design history in SolidWorks. It's just along the bottom down here. So we can go back and edit here, and I want them to actually, I want to create the top part also. And it might just be that they're not protruding through the top, because I might not have had such a large fillet on there. That might have created a problem because it's not going through a flat surface. Why don't we undo or we'll drastically reduce our fillet, and then we'll come back and see if I've got the oh, maybe I just need to tell it as a hook and a groove. But well, let me select that one. All right, let's cancel that, and let's go and back to our, these are the fillets. Why don't we just delete this fillets? Oh wait, we'll keep that one but delete the top one. Now let's see if we can get the actual holes to show up for the snap. But I want it to do, for some reason, it's not creating the hole part in the lid. And so this is a problem with new things, is I don't know all of the details for how to make, when something goes wrong. Like I want it to do that, and it won't let me select that one. Why won't it let me? All right, what if I unselect? But I want that one. Oh, I have to click the glue. Okay, so I have to tell it I also want the groove on there, I suppose. And I want the groove on this piece. There we go. So I guess I did that last time without even recognizing it. It's all right. We still might not could have the really extreme fillet that I had on there because I've got them so close to the edge that it might, I don't know. Let's put it back on there and we'll put it back on there and see if it updates it. But let's I have it 5, well, not 5 millimeters. It's actually 5 times T1. So it's a kind of programmatic type thing, parametric deal. And it has created all of the geometry, all of this geometry, the shape of the hook, the shape of the hole that it goes in. It's all created that automatically. Now I did find that the hole that it creates for this shape, if I make it protrude all the way through the thing, you lose the little ledge. So it needs to be kind of below the surface a little bit. I want it to be high enough that I can actually get in there to push the thing though. All right, so, oh, why do I have the hole is not, all right, we need to edit that again. Apparently the groove width L is set to 4 millimeters. Let's make that bigger, clearly. Let's make it, I don't know, 8. There we go. Now I did notice, let's zoom in on one of these things. When I actually made one of these, again, I've got it set really close to the edge. You might not want it that close to the edge. Let's hide the bottom. And this surface right here, this surface was kind of, it didn't give any room for the little peg to go in and actually move. There was no way for it to get in there. So all I did was I extruded it back to there. And that made it, now when I turn this back on, there's room for this to actually, bend over and actually make the snap part of the snap fit work. So there's probably one of the settings in the groove thing that actually does that, but I just did it this way. I just went in, selected that, hit E for extrude, and then extrude it back to that surface to delete it, basically. And now there was room for the little snap fits to work in there. So that's a pretty easy way. Now, again, I've got it really close to the edge here. That's probably not, I'd probably want that set in a little bit more. So we could go back to our shell command, and we might need the inside thickness to be maybe 2T. And that moves them in quite a bit. You can also, like this top part, if it's kind of in the way, you can either just hide it to see what's going on, or you can give it a material that's transparent. So if you give it an appearance, it'll open an appearance tab over here, and there are some, well, there's a metal, a glass one up there, but there's some of the plastics that are transparent. So you could give it this polycarbonate, and then you could see, oh, that's what's going on in there. You could decide if that was going to do what you wanted it to do or not. Kind of looks like it would work. They're a little bit tall, and they're going to be printed, layers on top of one another, which could be fragile. They shouldn't be they're going to be inside this thing, so the only issue would be, are they going to stand up to being snapped in and undone? I did find that I had to oversize the hole, the little hole that the snap fit is going into. I did have to oversize that because unless your printer is super well calibrated on the dimensions that it's going to print, if you over extrude any amount, then these holes might get a little bit smaller than they are designed to be. So I did have to go in on the ones that I printed over here and make the hole, this part, this whole part, a little bit larger to account for over extrusion when it was printing. Also, the way this is currently set up, this little ledge is really thin, and you would print it in a upside down way, so it might have some trouble printing this. I would actually probably thicken that up a little bit, and I would take this face. Whoa. This face, why is it selecting everything? I would take that face and bring it back there, just because it's going to be hard to print. So you do have to, again, the plastic tools here are not set up for printing. They're set up for injection molding, which does share some of the same rules about undercuts and things like that being difficult to injection mold and difficult to print. But you do have to go in and make sure that what you design or what it put out there as geometry is actually something that prints well. But I did find these to be pretty handy if you're trying to make some sort of enclosure. Let's see what happens if we add that fillet back. Let's go over here and just add this. Actually, let's edit this one. And let's add this to our list of edges to I didn't add. There we go. All right, so that one's a NR. That's I think it's nominal radius for that plastic rule that we set up. So it's much smaller than the 8mm radius I set before. So there we go. So that's a pretty cool tool. They also have boss tools. So maybe you want, instead of snap these together, you want to screw these things together. You would go in, let's do we have time? Yeah, we have time. Turn off the top. Let's create us a little sketch on this bottom surface, and we'll create a point to locate the, not modify, create point to locate where we want the screw pegs to be. Or maybe these would be, this little board doesn't, this board. So some boards have mounting holes. Maybe you want to locate those to set this on to mount a board in, or whatever. I'm just going to pick a point here and here. And now I've got these 2 points, and I can create a boss. Okay, I have to save the design. There we go. And let's try to create our boss again. And sketch points there. And all right, so what's it giving me for a preview here? I can do a boss, which a boss is just kind of like a thicker area where you're going to attach usually a bolt or a screw. This would be like a plastic screw. It does give you some options on, well, what kind of screw you're using, a 2mm, 3mm, what kind of screw are you using? Is it a, do you want threads in there, or do you want, these are all forming, so it does know it's plastic. Usually those are meaning that when you tighten the screw down, it's going to form the threads as part of that process. What kind of, do you want a countersunk hole, a counter bore hole, a straight hole? Does it go all the way through? What all this do you want? I don't even know what's in advanced. Oh, that's where you can have a little more control over the dimensions. Let's select the other one over here. There's no geometry. Uh-oh. What is it asking me to select right now? Sketch points I have. And it's... Can't tell. There we go. I'm just trying to figure out which one of these arrows to drag. So there I'm just dragging. I could drag it up a certain dimension. You can, I don't know if you can see it, but inside here, 5.1, I don't know, it's kind of maybe not putting the dimensions in the right or the best spot for visibility, but that's telling me how tall this is. I can make it different widths if I wanted to, or I could go over here and you know, select the ones from a drop down. Probably better off to do the drop down. Offset, I don't remember how. Oh, 10 millimeters is halfway, isn't it? And so there's the little boss, and it should, let's see. Oh, it didn't make the matching boss. I guess I didn't have it selected to make the matching one. Let's see. Side 1, side, there we go. More, not a pan head, but that'll work fine. Let's change that back to 10. And I think those are the selections that I want. Although it's now I've lost the deal. Where's my... It doesn't let me choose exactly what I want to choose here. Oh wow. I've got an extra point in there somehow. That's why I was doing that, I don't know. Let's see. Oh, do I have to have a matching point on the other side? I'm not sure how to get it to make the top part on this boss part. I haven't used the bosses. I've only used the, what you call them, the snap fits. So I have to look at the boss on how to use that. But, well, I guess I can make the bottom part of the boss. I can't get it to make the top part of the boss. I have to look and see what button I didn't push. But anyway, these tools are pretty handy for quickly creating plastic features. You know, there's also ribs in here. I think the ribs, well, that's a web, but there's a rib. I think the ribs work the same way, where you go in, create a sketch with basically the pattern that you want the rib to be in. Maybe you just want a rib across there. And I think we can just select that for a rib, and we can, I don't know why the previews are not doing what I think they would do. So, I don't know. It seems like that would be, I want it to start from the bottom. This is the sketch, which is selected. The thickness is a bit much, but for whatever reason, it doesn't want to actually I wonder if I have to give it a draft. The draft direction is whenever you're injection molding things, you don't want perfectly vertical sides. You want them a little bit angled. And that's called draft, so that you can actually pull the injected part out of the mold easier. But I don't know if I actually need that for the snap fit parts, because they actually work pretty well. I did, I remember one other thing. After the part was made, I thought that these little edges here were a bit tenuous, so I did go in and add a fillet to them. Just to, I guess I did it one at a time. Just to make it a little less likely to just snap off right there. It might be tough to add a fillet on this back side because you want it to close against it, so you'd have to make clearance for that fillet on that side. We're pretty close to out of time though, so I don't know if I can give you any other little pieces. Oh, there is one other thing that I did here. So on this part, oh, is it going to show up? Probably not. Probably not. Let's at least turn the screen off so I can see what I'm doing. You can kind of tell I did create a little lip. Maybe it shows up better on these parts. Little lip and a matching one inside here. That's not really a plastic tool necessarily, but what I did, maybe we can do that sort of quickly. What I did is I just cut away, you know, the edge here. So maybe if we go to this view, and what did I do? Let's make a little plane in the middle. So we'll construct a mid plane between here and here. That plane, and I sliced it on that plane so I could actually see the edge here, and I just made a little rectangle, and I dimensioned. I think I made it. You have to find a corner to dimension from. Let's see, that's 1.5. Let's make it 1.4, and then let's make it so deep. Oops. That way. Let's do 1.4 again. So there I've got this little edge. It's actually extending out past it, but that's okay. And now what you can do is you can do a sweep of this profile, which is the little square we just drew, and a path of the edge around it, and make sure it's on cut. And then you've got a little ledge that you can snap together if you want it to kind of not be watertight, but you know, maybe a little bit of debris tight or something. And then you make the matching one, but you do have to again account for when you print things, they don't end up exactly the right dimensions. There's a little bit of overflow extrusion, or maybe some under extrusion or whatever, and so this ledge, you would probably, I made this go in and down 1.4 millimeters. So on the matching part that goes in it, maybe you'd only want that 1.2 millimeters deep and wide. This kind of goes back to the early on, we did the little tolerance test, and you could that was more about the gaps between two parts, but it was also telling you about how accurate your printer is at resolving a certain distance. And so if you could open up the tiniest of those little pieces, then maybe you can do 0.14 and 0.135, and you know, just have a 0.05 millimeter tolerance in there, and it's okay. But I never was able to get this particular printer to resolve that well, so I had to open them up a little bit more than that. The gaps, open them up a little bit more. But so that's a couple of ways on how you can add snap fit pieces. Again, I think just looking at this, I think that's probably too thin, so you probably would want to make this a little bit thicker. I wouldn't edit this piece by just pushing and pulling on it here. I would go back to the snap fit and edit their dimension A, and it's T1/2. Maybe just make it T1 thicker. And so now we've got a much thicker tab here. That also changed our hole So you have to make sure it didn't make it where that doesn't print, but actually that looks okay. You might be kind of tight on getting this tab to go through this slot, though. You might want to open the slot up a little bit more. Or I think there might be a taper that you can add to the little tabs. Anyway, those are some tools. If you have the education license of Fusion 360, which all you have to have is a .edu account email, then you've got these couple of new things that you might want to do. They kind of help speed up, once you learn how they work, they help speed up making some of this geometry. Maybe the bigger thing they do, though, is that now these are features that you can go and edit just like we did. Maybe you find out, oh, they really need to be wider, they need to be narrower. You don't have to go back to your sketches and everything that you used to create that geometry and edit those. You can just go back to the feature and edit the whole feature in one go. Plus, them being contained in a feature like this makes the whole design, if I want to change the length, if I want to go back here and say, oh, I was wrong, it needs to be 150 millimeters, then, everything does, well, something didn't upright. I got a warning on extrude 3. I don't remember what that one was. This guy, which I don't even see what that's doing. We'll just delete it at some point. But it updates everything the way you would want it to update. Whereas maybe depending on how you design the little tabs and slots and everything beforehand, maybe not all the dimensions get updated correctly. So it does add a little bit more flexibility when you're having to iterate on things. Like on this one, I've got to reprint this a little bit longer to fit another component in here. And it's easy to do the way it's set up. I just change that one dimension, and everything else automatically updates and propagates throughout the model, and you print a new one without having to go and change a lot of things. That's pretty typical. SolidWorks does the same kind of things. It's just a nice feature to have, and make it that if you use it anyway. All right, that's just some more stuff. We'll be back next week. Next week we've got the annealing going on. Probably we'll try the chocolate printer. I still have been reluctant to really get into that and see how it works. Got some other types of like multi-material printing type things that we haven't done. We've done multi-material where we've just changed out the filament, but in here we've got some multi-material where you just feed in multiple materials and the machine selects the one it's going to use, prints a while with that one, selects a new one, prints with that one for a while. So we'll look at some of that kind of stuff. Those are what's kind of coming up. If there's a particular topic you want to look at, then let me know, and I'll see if I know anything about it at all, and we can add it to our list too. All right, I will see y'all next week.